Elon Musk was highly optimistic about nuclear power, and it looks like he was right about it. Almost all nuclear energy in the world is generated using a process known as nuclear fission. But we are now witnessing a major breakthrough in the way a nuclear reactor will work in the future, which might change the way we look at nuclear energy. So what exactly can we expect with this new breakthrough in the field of nuclear energy? Well, that's exactly what we discuss in this video, so make sure to stick around till the end to know how nuclear fusion would change everything we know about nuclear energy. About 500 years ago, the Aztec civilization in today's Mexico believed that the sun and all its power were sustained by blood from human sacrifice. But with all the technological advancements that we have today, we know that the sun is powered not by blood from human sacrifice, but by a reaction called nuclear fusion. Nuclear fusion was understood as early as the 1930s. Scientists have been focusing on recreating and harnessing the same to produce energy on our planet, similar to what we have with our sun. But most of these attempts were highly confidential. Once scientists realized that the entire process is costly and requires a lot of research, they understood the fact that any significant development is only possible through collaboration. So during the Second United Nations International Conference on the Peaceful Use of Atomic Energy, held in 1958 in Geneva, Switzerland, scientists unveiled nuclear fusion and its potential. Several plasma physicists and experts in various multidisciplinary fields of fusion science and technology have been exploring key physics and technological issues, as well as several innovative concepts of direct relevance to the use of nuclear fusion as the future source of energy. Now you might be thinking, how exactly does nuclear fusion work? Well, nuclear fusion is a process by which two light atomic nuclei combine to form a single heavier one, while releasing massive amounts of energy. Fusion reactions take place in a state of matter called plasma, which is a hot, charged gas made of positive ions and free-moving electrons with very unique properties that are very distinct from solids, liquids, and gases. These nuclei need to collide with each other at extremely high temperatures, something that you would find on the sun. When we say extremely high temperatures, we're talking about 10 million degrees Celsius. This is done to overcome their mutual electrical repulsion. Once the nuclei overcome this repulsion and come within a very close range to each other, the attractive nuclear force between them will outweigh the electrical repulsion. And that's how these two light atomic nuclei combine to generate all that energy. But for this to happen, these atomic nuclei must be confined to a small space to increase the chances of collision. When you take a look at the sun, the extreme pressure produced by its immense gravity creates the right conditions for fusion to happen. Replicating that kind of condition is going to be extremely difficult on our planet. But once we're able to do so, it will make huge headlines, and we might be able to completely depend on nuclear energy in the future. This is because the amount of energy produced from fusion is very large, at least 4 times more energy than nuclear fission reactions, which is how nuclear power plant reactors produce energy today. There are several industry experts working on creating the very first generation fusion reactors, which will be using a mixture of deuterium and tritium, both of which are heavy types of hydrogen. So in theory, a few grams of these reactants can produce several terajoules of energy, which is approximately the energy one person in a developed country needs over 60 years. So we're not talking small numbers here. When you take a look at the sun, its massive gravitational force naturally induces fusion. Without that force, higher temperatures needed for the reaction to take place is almost impossible, especially on Earth. We need temperatures exceeding 100 million degrees Celsius and intense pressure to make deuterium and tritium fuse and create sufficient confinement to hold the plasma and maintain the fusion reaction long enough to gain a lot of energy. We're talking about net energy gain, which is the ratio of fusion power produced to the power used to heat the plasma. The conditions that would facilitate nuclear fusion can now be achieved through several experiments, but improved confinement properties and stability of the plasma are still questionable. Scientists and engineers from all over the world continue to test new materials and design new technologies to achieve fusion energy. And it looks like they did find a way to achieve fusion energy, making it one of the major breakthroughs in our attempt to make nuclear fusion a reality. On August 8, 2021, about 192 laser beams were pumped more powerful than the entire US electric grid into a small gold capsule and ignited for a fraction of a second. The same thermonuclear fire that powers our sun. The results of the breakthrough were published in a 3 peer-reviewed journal. The experiments occurred at Lawrence Livermore National Laboratory's National Ignition Facility in California in 2021. According to Discovery magazine, nuclear fusion has been considered to be the holy grail of energy research ever since it was theorized in the 1920s by English physicist Arthur Eddington. This latest breakthrough may be one of the most significant steps yet towards human application of nuclear fusion. The data from this experiment and its continuous follow-up will aid researchers to further streamline the fusion process and explore nuclear fusion as a real alternative to nuclear fission for electricity generation. What makes this a breakthrough lies in the fact that researchers were able to achieve ignition, which is a point at which a nuclear fusion reaction becomes self-sustaining. Now, this is a huge deal because ignition is a fundamental step towards humanity's ability to use fusion to generate electricity. Researchers argued that the ignition they achieved is a crucial step, proving that controlled nuclear fusion is achievable. But then, there are certain controversies surrounding the definitions for ignition. It's extremely exciting to have a proof of ignition in the lab. This will be an incredible opportunity for scientists to expand on their knowledge as they continue to make progress because they are operating in a regime that no researchers have had access to since the end of nuclear testing. None of this was an easy task. It is a result of years of research and work of so many people. Today, nuclear fusion and plasma physics research are carried out in more than 50 countries, and fusion reactions have been successfully achieved in so many experiments without demonstrating a net fusion power gain, which is extremely important if we want to make nuclear fusion a practical energy source. We don't know how long it will take to recreate this process found in our closest star, as it will entirely depend on mobilizing resources through global partnerships and collaborations. It is expected that nuclear fusion could meet humanity's energy needs for millions of years. Fusion fuel is plentiful and readily accessible. Deuterium, for instance, can be extracted inexpensively from seawater, and tritium can be produced from naturally abundant lithium. A fusion plant would produce abundant energy using only hydrogen from water as fuel and producing helium as waste, without the risk of meltdown or radiation, which is positive news. The future fusion reactors will not produce high-activity, long-lived nuclear waste, and a meltdown in a future fusion reactor is practically impossible. More importantly, nuclear fusion doesn't emit carbon dioxide or other greenhouse gases into the atmosphere. These new studies suggest that researchers are willing to keep exploring what the National Ignition Facility is capable of, unlike other fusion researchers, because the researchers at the facility are not primarily focused on developing fusion power plants. They just want to understand thermonuclear weapons. The demand for sustainable sources of energy is going to be a lot higher considering the fact that so many people are now switching to electric vehicles. We also tend to use so many gadgets today, all of which require electricity to power them. Nuclear power has enough positives to be a solution for the existing power crisis, and the benefits of nuclear energy might actually surprise you, especially if we are able to implement nuclear fusion. The potential advantages of nuclear fusion energy are manifold, as it represents a long-term sustainable, economic, and safe energy source for electric generation. There are so many that there are several researches being done on nuclear fusion. So sometime in the future, we might be able to power our entire world with the same energy that powers our sun. As of now, building a fusion power plant that can withstand the immense temperature of about 100 million degrees Celsius and pressure makes this entire thing one of the century's greatest enduring challenges. If we could replicate nuclear fusion on Earth, we could finally unlock virtually limitless clean, safe, and affordable energy to meet the world's energy demand, especially when the fuel is inexpensive and abundant in nature, and the amount of long-lived radioactive waste and greenhouse gases produced through diffusion are minimal.